Use the implicit differentiation to find y prime and evaluate y prime at the indicated point, and the point here given as is -1, 3. So on this example, we have given an implicit equation, and our goal is to find y prime first. And once we evaluate the y prime, once we find the y prime, then we need to evaluate y prime at the given point. So let's then first find y prime by using the implicit differentiation. So since we have given here an implicit equation, so how can we implicitly differentiate and then find y prime? We have the kind of two-step process, right, which is first we need to differentiate with respect to x on the both side, right, and then after that we need to solve for y prime. So if that is the case, let's try to first differentiate with respect to x on the both side. So we need to differentiate 2x cube y with respect to x, and then we need to now then differentiate with respect to x for x cube, and then we need to differentiate with respect to x for 5, and this is possible because of the sum and difference rule, right? And we can do that and then do the same thing over here, differentiate with respect to x for 0. So let's try to do this one over here. What is the derivative of the 0 with respect to x? 0. What is the derivative of the 5? There is a constant here. When you differentiate with respect to x, what do you get? 0, right? And then what is the derivative of the x cube with respect to x? That is 3x square, right? And then we can carry the minus sign over here, and then now just need to focus on finding the derivative of the first term, which is 2x cube times y, and y is a function of x, so this is 2x cube, a function of x, times y, a function of x. So we have the product function, so we need to use the product rule, and which can be then done by 2x cube, write that down as it is, multiply by the derivative of the y with respect to x, which we can write down as y prime, right? And then plus derivative of the 2x cube with respect to x, which is 2 times derivative of the x cube. Derivative of the x cube is 3x squared, so 3x squared times 2 will be 6x squared, and then times y. So that is by the product rule, right? So we differentiate with respect to x on the both sides. So now the next thing is we just need to see if we can solve for y prime. So let's try to see which term has y prime. So this term has y prime, and then the remaining term doesn't involve with y prime. So if that is the case, we can isolate the y prime term by subtracting 6x square y on the both side and then adding 3x square on the both side. And on that case, we can just isolate y prime by dividing by 2x cube on the both side, and when we do that, we find the y prime. But we can simplify this further. If you take x is negative, what can you take out here as a common factor at the top? We can take 3x square out as a common factor. When we do that, negative 2y is the remainder on the first term, 1 is the remainder on the second term, and underneath that we have 2x cube. And if you properly simplify this at the top, we'll have 3 times negative 2y plus 1, and then at the bottom we'll have 2 times, yeah, at the top we have x square, at the bottom we have x cube. When you combine, let's say factor it out or cancel out the common factor there, we actually get just x, right? Or you can use the exponent, however you want to explain, but this is your y prime. Okay, so we find the y prime. The next step is to find y prime, right? Evaluate y prime at this given point over here, -1, 3. So let's do that. So we need to find y prime at -1, 3, and this is just like evaluating the function, right? So in that case, 3 is there, -2 is over here as a given function, the y prime, and then we have -2 times y. Y is the y coordinate of the point, plug that number in, plus 1, and everything under that will be 2 times, we have x here, need to replace by the x coordinate of the point, so fill that in. So in that case, we get at the top 3 times -2 is -6, plus 1 will be -5, divide by 2 times -1 will be -2, so we end up with -15 over -2, which is actually 15 over 2, right? And then this is the y prime at -1, 3.